I think remember in the last session we discussed about this different physics concepts. Okay, so we have some more concepts to discuss related to this physics which is used in HVAC. So we end with the sensible latent in the previous session and also discussed about the other concepts. So in this session, let me continue with the pressure. Okay, so first we'll talk about the pressure. And you see, pressure is very, very important. We'll discuss in detail. After that, we'll talk about laws of thermodynamics, especially the second law of thermodynamics, which is used in HVAC. Then we'll deal with the refrigerants. After that, we'll talk about vapor compression cycle. Okay, and without this vapor compression cycle, it is difficult to deal with the classification of air conditioned machines, because right from window till this chill water system or chillers, you'll find vapor compression cycle. You'll find the other options also like vapor absorption, but most commonly in actual practice, you'll find this for commercial and residential units, you'll find vapor compression cycle. Okay, so in this session, I'll complete this chapter 3 so that we can deal with the psychometry, which is chapter 4 in the next session. So I'm going to share the screen. So on screen, you can find out the term pressure. So as a mechanical or as an electrical or as an engineer, you're already aware of this pressure. But as I said in the previous session also, we'll discuss this concept for application point of view, because we'll use this in the calculation. So you must know the application of this. Okay, so it's simple. If I ask this question or if it is asked in an interview, so you can easily define pressure is what? Pressure is what online?
Force per area.
So
per unit area.
yes, you can add this term unit. Okay, this is important. So no doubt it's a force per unit area. This unit area is important. Suppose if I compare this pressure and force, in force we are not considering area. Force is a push or a pull. It's a vector unit. But in case of pressure, whenever we talk about the pressure, we are considering a force per unit area. This unit area term is important. Okay, if you not consider this unit area, means you are not talking about the pressure. We are talking about the force or total pressure, etc. But when you talk about pressure, we are considering always force per unit area. Okay, so this unit area is very, very important. So let me quickly read some theory, then we'll continue. So you see, pressure is defined as the force applied per unit area. This is important. In other words, it's the amount of force exerted on a surface divided by the area over which the force is applied. Okay, mathematically, you see, pressure P is what? Force per this area means by default we'll consider unit area. Okay, so we'll not consider the total area, it's a unit area. Unit area means it can be a square mm, or it can be a square centimeter, or it can be a square meter or square feet, etc. So when you consider a unit area, then we can consider as a pressure. Further we'll discuss, we'll try to understand the concept for this. So here on screen, the unit for the pressure. So you know this. So you see the unit for the pressure in SI is Newton per square meter. So you can consider here, or you can see here, square meter is a unit area. Na? Similarly, in actual practice, we are using this term PSI. PSI is what? Pounds per square inch. So you see again, this is a square inch unit area. So pound is a unit of force and per unit area means square inches. Similarly, we can consider this PSF pounds per square feet, or Newton per mm square, Newton per meter square, or this kg per centimeter square. So these are the different units for pressure. So in all this, you'll find this unit area. Okay, so this unit is important. So let me give you an example so that you can able to relate this. On the left side of the screen, you can find out force for a particular area. Further, to understand the concept, let me give a simple example. So everyone aware of this tire. This can be a two-wheeler or four-wheeler tire, and you know this. Generally, we are filling the air in the tire. It can be a tubeless or it can be tube tire, and most commonly, we'll fill what? 30. What 30?
PSI.
Right, 30 psi. Psi is nothing but pounds per
Square
inch. So this unit we are using LB is a pound per square inch. So pound is a unit of force per square inch. So what it mean exact? 30 psi. It means what? It
per
means
inch square. Per inch square, 30-pound force will be applied.
yes, exactly. For example, if you check inside this tire, for example, for 1 square inch, suppose this is 1 inch, this is 1 inch. So this is 1 square inch, no? So how much pressure or how much force is acting? The force is acting of 30 pounds. Okay. So for 1 square inch, the 30 pounds of force is acting. So we can say 30 psi. Okay. So this is not the total, because here we are talking about the pressure. So pressure means we'll consider per unit area. This unit area is very important to understand. And why we're discussing in detail, because when you talk about this air side or water side, not only in HVAC, even for this plumbing, firefighting, when you will use this term pressure, because we'll talk about this head required, head loss due to friction, or total head required for selecting the pump, or even for this fan. So you must understand, or you must know the concept of pressure. Later we'll talk about the total pressure. Total pressure is what? Static plus dynamic. So further we'll discuss about this pressure in the future classes, for this fan or for the pump, etc. Okay, at this level, just try to understand the basic concept. What is pressure? Pressure is what? Force per unit area. So I have some more examples for you, so that you'll get, or you can try to get more clear idea. So I think everyone aware of this. Pressure is directly proportional to the height of the liquid column in case in the fluid mechanics. For example, if I consider a base, in that base I'm just placing one pipe, say this pipe of say 30 feet. Beside this I'm placing one more pipe, this also 30 feet length. Now in this first case, I'm going to fill the water up to the maximum, say up to 30 feet maximum length. But in the case 2, I'm going to fill the water only half, say 15 feet only. Okay. So here at the bottom, P1 will exit and here P2 will exit, right? So what do you think? In which case you'll find more pressure?
P1.
P1,
One.
obviously. Because,
Height of
yes, you
water
see,
column is
height of the liquid column is directly proportional to the pressure. As the liquid height of the liquid column increases, the pressure at the bottom increases, right?
yes.
Everyone aware of this. So now with reference to this, I have one small example. Now in this example, you see I'm considering this 4 container. Container 1, container 2, this is 3, and this is 4. And you can see in all this container, I fill water. Assume that it's a liquid, the same liquid, say water. And I'm considering this container A height as H1. This container 2 also H1. Container 3 also H1, and container 4 also H1. Means I'm maintaining the same level, or I can consider the same level of liquid column. Okay, means the height of that liquid column is same in 4 containers. Okay, so now based on this liquid inside, or as per the height of the liquid column, here you'll get P1, here you'll get P2, here you'll get P3, you'll get P4. So now the question is, in which case you'll find more pressure?
Height of the water column is same, right?
Yes, you see H1, 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 and H1.
Same pressure will be.
Okay, I got answer from Mr. Anish. What about other participant?
It is depend upon the area and mass of that liquid.
Mhm. So what about other participant today? Okay,
It is
Ajay.
depend upon the area.
You see, what Mr. Anish said, that is correct. You see, since the height of the liquid column, since the height of the liquid column is same, so P1 equal to P2 equal to P3 equal to P4. So the pressure is going to be same in all the container. So again, back to back to the basic concept. Pressure is what? Force per
Unit area.
unit area. For example, if I check here at the bottom for 1 square inch, same at the bottom for 1 square inch, and here also for 1 square inch, and for here also 1 square inch. Since type of the liquid is same, as I said, water, and the height of the liquid column also same, so per unit area, the force is going to be same, na? So that's the reason. Remember, as the height of the liquid column, if the height of the liquid column same, whatever the shape of the vessel, that will not affect to the pressure, because pressure is what? Pressure is force per unit area. If you talk about the total force, that is going to be different. That depends on the volume. If you talk about but if you talk about the pressure is going to be same in all the container, because pressure is what? Force per unit area. And here one more point, the density of this liquid column is same, because I'm using water in all the containers. Getting a point online? So remember, this is very, very important. And the same, I'll prove this quickly. Let me delete this image. Now you see in this image, this is a experiment. You can see height of this liquid column, this liquid column, this liquid column is same, but the shape of the vessel is different. So you see in this example, this is a practical example. The pressure gauge is added. So since the height of the liquid column is same and the type of the liquid also same, you can see the pressure reading in all the gauges is same. Na? So now the conclusion is, pressure is what? Pressure is force per unit area. I think you got the idea, and now you can relate about the pressure, the importance of the unit area. Later we'll talk about more detail about the pressure, different types of pressure. Like again, if you talk about in general, we have absolute pressure, we have a gauge pressure, we have a total this absolute pressure, gauge pressure, and one more atmospheric pressure. That is in general. Again, further, if you talk about this this fan selection, we have a static pressure, and we have this velocity pressure. Again, in case of this water side also, we have this dynamic pressure or the total pressure or this static pressure. So all this we'll discuss in the future classes when we talk about this fan selection and the pump selection. At this level, I think you got the clear idea about the pressure. Okay.